All right, so differential equations, just so you guys kind of know what this is or like what the significance of this is. With differential equations, like when I was in college, I had to take 4 different calc classes, right? And differential equations was an entire class in itself. So what we're doing right here is just like scratching the surface, just the tip of the iceberg. Differential equations, if you go forward in like math or engineering or science or anything like that, you're going to have like whole math classes of differential equations. It's kind of a really big topic in calculus, but we'll just introduce it here. Okay. You don't have to write this down if you don't want to, but it's basically kind of the definition of a differential equation. It's an equation that involves x, y, and derivatives of y. So the equation could have y prime in it. It could have y double prime in it. This would be an example of a differential equation. It has multiple variables and it has derivatives of those variables all in one equation. Okay, another example, and I don't know that we really get into this sort of stuff in here, but you could have equations with like first and second derivatives in it. So multiple variables, multiple derivatives. That's what a differential equation looks like. Okay. Okay. The goal of solving a differential equation is to take this starting equation, whatever it is, and basically integrate it and get back to the original equation. And with multiple variables and multiple derivatives in the equation, it gets pretty complicated. That's why they have like whole classes for this. But what we're going to do today is 2 things. We're going to talk about graphing, like taking this and graphing the original equation with something called slope fields. And then at the end of class or towards closer to lunch, we're going to do something called separation of variables, where we actually like solve this by hand. Okay, so separation of variables and slope fields are 2 things we're doing. Again, you don't have to write this part down. I just want to show you what a slope field is. If you have a differential equation, let's say it's like this one right here. A slope field is a representation of what that original function may look like, and it all depends on the constant. So you know how when we integrate stuff, we always have to write like the plus c at the end, okay? So take, for example, this black line down here. That represents one possible solution to a differential equation. But if your constant is different, if you change your constant, it could be this red line, it could be this yellow line, it could be multiple possibilities depending on like what your constant in your original equation looks like. Okay, positive, negative, whatever. Okay, what we're gonna do today is come up with a slope field and just show you how to like estimate what a graph would look like through that slope field. Okay. All right, this is where you want to start your notes, I think. I think I'll do 2 kind of basic examples with you guys. Have you try a couple on your own, and then we can have some practice time. Max, do you have a question? Yes, they actually are on Canvas. I think they are. Maybe I didn't. Let me check. Do you need it just to see back there? Okay, yeah, let me check right now and make sure. All right, I guess I didn't. Thanks for catching that. Let me give me like 2 minutes here. Just got to convert it to a PDF and post it.